You are welcome to online lectures with Pharmaceutical School Board. Today, we'll take a look at pharmaceutical calculations. Pharmaceutical calculations, and we have a question on the board. We have a question on the board. Okay, excuse me. Okay, take a look at this question. The question says, actually this question was sent to me by one of my students. I deemed it necessary to solve it here. The question says, calculate the amount of sodium chloride that should be added to the following formulation of nasal drops in order to make the final solution isotonic. Okay, the formula is ephedrine hydrochloride, B value 0.169 degrees Celsius. The amount is 0.5 gram. Then water to 100 ml. Water to what? 100 ml. Okay, now to solve this question, we should understand something here. That this type of isotonicity adjustment does not use the concentration. It has nothing to do with the concentration now. This has to do with the freezing point depression. What I mean concentration, I mean by implication, osmotic pressure. Remember the properties of solution. Remember the properties of what? Solution. Where we talk about those properties that does not depend on the nature, but on the what? Concentration. Remember those properties. Freezing point, depression. Boiling point, elevation. Osmotic pressure. And vapor pressure, depression. Now, these properties two of them are used in the adjustment of the tonicity of solution. Mainly, we have the solution pressure and we have the what? Freezing point depression. Because from the origin of solution, once you add a solute inside a solvent, a lot of things will change. The solvent, a lot of physical properties of the solvent will change. A lot will change. The boiling, because it's no longer pure. You got an impurity. That's what there is, an impurity. So the freezing point of the solvent will do what? Depress. So we use that freezing point depression to determine the tonicity. Because it has been discovered that the body fluid has freezing point depression of minus 0.52 degrees Celsius. Minus 0.52 degrees Celsius. That means the freezing point is depressed by 0.52 degrees Celsius. It had also been discovered that 0.9% within volume of sodium chloride in solution has this freezing point of minus 0.52 degrees Celsius. That means if you get 0.9 gram of sodium chloride and they dissolve it in pure water and make it to 100 ml, pure water on its own has freezing point of what? 0 degrees Celsius. When you now add sodium chloride, it will depress the freezing point of pure water from 0.0 degrees Celsius to minus 0.52 degrees Celsius. They were depressing it by 0.52 degrees Celsius. So this sodium chloride solution, 0.9% sodium chloride solution, has been found to have approximately the same effect, the same freezing point depression with the body fluid. This is a very important discovery that is used to adjust the tonicity of what? Preparations, both the ones ophthalmological preparations, even parenteral IV fluid and what have you. So, having that at the back of our mind, we'll see bring back that sodium chloride back, 0.9% sodium chloride. Or if you don't want to use 0.9% sodium chloride as 0.9% sodium chloride depresses the freezing point by 0.52 degrees Celsius. If you don't want to use that, you can fall back on the B version caused by 1% within volume of that substance. 169 degrees Celsius. What it implies is that 1% within volume of ephedrine hydrochloride has a meaning. And it has been discovered that B value of sodium chloride is what? 0.5, caused by 1% within volume of what? Sodium chloride. So this is the B value of sodium chloride. Now, how do we now come here? Look at this thing critically. To make this thing isotonic, we should first of all check whether this thing on its own is even isotonic. Because if it's isotonic, no need trying to make it isotonic. There's one question, I keep saying this. Not any question you see that they ask you to make a solution isotonic, you rush and start calculating what you don't know. Calm down. Determine if the solution itself is isotonic before you do anything. Determine if the solution itself is isotonic before you do anything. So let's look at this thing. We will find out first if this thing is isotonic. Everything is in 100 ml. For this thing to be isotonic, the freezing point depression of this solution must be 0.52 degrees Celsius for it to be what? Isotonic. So if it is not up to 0.52 degrees Celsius, this is not what? Isotonic. That means we need to find out what we need to do. We need to determine the amount of sodium chloride to be added to make it what? Isotonic. Now, to determine if this is isotonic, we really have our B value to be 0.169 degrees Celsius. That means 1% of this costs 0.169 degrees Celsius. So we need to determine, since we know 1% is 1 gram in 100 ml, so 1 gram in 100 of this ethylene hydrochloride in 100 ml will depress freezing point by 0.169 degrees Celsius. But we have 0.5 gram here. So how many, if 1 gram in 100 ml we depress by this, how many, by what degrees Celsius will 0.5 gram? Is probably half of this one, which is around 0.8 something. Let's do the calculation so we don't say everything like that. So now let's do the calculation. Let's start from here. Solution. Think I've given enough theoretical background. Let's now go to calculation. So solution. Okay. Here we have that B value of ethylene hydrochloride is what? 0.169 degrees Celsius. From my explanation, that means 1% weight in volume of ethylene hydrochloride depresses by what? 0.169 degrees Celsius. That's the meaning. So remember that the 1% weight in volume is certain as saying 1 gram in 100 ml. Thank God the entire solution is in 100 ml, so there's no need try to convert it again. So simply say at 1 gram, everything is 100 ml. That 1 gram will be pressed by what? 0.169 degrees Celsius. Or if you don't want to go into that, but I think that we let's go like that. It then implies that 1 gram of every hydrochloride will depress by 0.169 degrees Celsius. But we have 0.5 gram of ethylene hydrochloride here in 100 ml. So simply say 0.5 gram of ethylene hydrochloride will not depress by what? X. So let's find this X. Let's come up here. X is now equal to what? We cross multiply 0.5 gram times what? 0.169 degrees Celsius all over 1 gram. Gram will cancel gram. This is half of this. Half of this is 0.845 or so. 0.845. I think so. Yeah, that's what it is. 0.845. But let's not let's be factual. Times 0.169. Yes, I got it. 0.08. 0.08 watts, 45 watts gram. 0.0845 grams. So not grams, sorry. Degrees what? Celsius. So look at this thing. Look at this thing. Using the setting a proportion with the B value of ethylene hydrochloride, we realize that this solution will only depress the freezing point of water by what? 0.0845 degrees Celsius. This alone will tell you that this thing is hypotonic, because for it to be isotonic, it must depress by 0.52 degrees Celsius. For it to be what? Isotonic, it should depress by 0.52 degrees Celsius. For it to be what? Isotonic. So let's find the difference to check the further depression we need to make it isotonic. So let's just check the further depression that we will need to make for it to be what? Isotonic. And that further depression is subtracting this, the extent this can go from the extent that is required. So subtracting the further depression we need is now 0.52 degrees Celsius minus 0.08 what? 45 degrees Celsius, which is what? This is 0.52 minus 0.0845. 0.52 minus 0.0845 is what? 0.4355 degrees Celsius. This is the further depression we need to make this solution isotonic. So what can cause this depression? We can, this is the extent this can go. So what do we now do? At this point now we add sodium chloride. So how do we now know the amount of sodium chloride to be added? Since we know that 0.9 gram, 0.9% of sodium chloride causes depression of what? 0.52 degrees Celsius. This has already been established. Or we can use this, or you can use the B value of sodium chloride. Any of them can go. You can still say, since 1% sodium weight in volume sodium chloride depresses by 0.576, any of them is okay. We can set proportion with any of this. Anyone use this, okay. But let me try to tell them to show you that they are total and we'll give it the same answer. Yeah, let's go. Let's start with the first one. So remember that 0.9% weight in volume of sodium chloride is certain as saying 0.9 gram of sodium chloride in 100 ml. Because everything here is in 100 ml, we just use 0.9 gram. No need doing further conversion. So simply say 0.9 gram of sodium chloride will be pressed by what? 0.52 degrees Celsius. So if that is the case, what gram of sodium chloride will depress by 0.4355 degrees Celsius? We don't know, we call it X. X is now equal to what? 0.4355 degrees Celsius. 0.4355 degrees Celsius. So we cross multiply. X is equal to what? 0.9 gram times 0.4355 degrees Celsius over 0.52 degrees Celsius. So the answer is what? So we have 0.9 times 0.4355 divided by what? 0.52. So we have 0.75375 gram. I will approximate this to 0.75 gram. I will leave it as 0.75 gram. Let's work with this and see what we come up with. Let's work with this and see what we come up with. Remember, this 1% weight in volume, this is the B value of sodium chloride. Remember, 0.576 degrees Celsius. So that means 1%, 1 gram. This 1% also means 1 gram in 100 ml. That means 1 gram of sodium chloride in this 100 ml depresses by 0.576. So if 1 gram of sodium chloride depresses by what? 0.576 degrees Celsius. So how many grams of sodium chloride X would depress what? By 0.4355 degrees Celsius. So X, we cross multiply. X is now equal to what? 1 gram times 0.4355 degrees Celsius over what? 0.576 degrees Celsius. So if we point the calculator, we have something like this. We have 1 times, of course, degrees Celsius, we cancel degrees Celsius, just the same thing here. Remaining grams. So we have 1 times 0.4355 divided by 576. So this will give us 0.7556 gram. 0.756 gram. So if we use 0.58, okay. So using 0.576, you have 0.756 gram. Then when I told you that some things here, you also use 0.58 degrees Celsius. And if you use 0.58, you have 0.75 gram. So this is just approximation issues, but they are what? The centimeter. They still give you what? 0.75. So I will take 0.75 gram. I will take 0.75 gram. Because 0.58 still give me 0.75 gram. 0.576 gave 756. I'm going 0.76. Take 0.57 gram. I'll take 0.57 gram. All right, so now the answer is what? 0.75 gram, not 57, sorry. 0.75 gram. That's the answer to the question, 0.75 gram. Here now, as you can see, that if you get sodium chloride, 0.75 gram of sodium chloride, and they add to this, everything in 100 ml, isotonic solution of ethyl green hydrochloride. That's the answer. So I don't know if you have any question, please feel free to ask. If there's any area that what I did is confusing, please feel free to ask. Call this line. Call any of these lines, 08138682003. You can also call 07012945891. Call. We have 2 minutes to do that. Excuse me. Ask your question. Question time. Ask your question. We are live. Ask questions. Ask questions. We are live. We are live. Ask your question. You can as well send your questions, send a chat on YouTube. I'll reply. If you don't have any time to call, you can as well send a chat, then I'll reply. I'll answer the question here. Okay. In the absence of any question, we stop here for now, for today. Please, I want to go into another thing before we call it a day. I wanted us to stop, but there's still time, so we can solve more questions. We can solve more questions. Okay, so let me get more questions for us to solve. As I said, if you have any question, please, you may not even need to call. Just drop your questions on the chats, on the comment section. I'll see the questions and answer your questions live here. If you have any question, please. Okay. Okay, let's look at this question. Let's look at this question. Okay, look at this question. The question says, take down ephedrine sulfate 0.5 gram, sodium chloride QS, sufficient quantity, purified water, add, as in make it up to 10 ml, make isotonic solution. Signia, use as what? Directed. The question now says, how many milligrams of sodium chloride should be used in compounding the prescription above? Please, for us to solve this question, we should understand one thing. One thing is what we should do was understand. This isotonicity adjustment has to do with the use of what? The osmotic pressure. That means we need to look at the sodium chloride equivalent of this ephedrine sulfate before we can even do anything. What is sodium chloride equivalent of ephedrine sulfate? A very important question. So if we know the sodium chloride equivalent of ephedrine sulfate, then we can solve this question. If we know the sodium chloride equivalent of ephedrine sulfates, we can solve this question. Okay. Now, for ephedrine sulfate, the sodium chloride equivalent is 0.2. It's common anyway. 0.20 ephedrine sulfate. 0.20. Now, we should first of all, I keep saying this, don't jump and start solving what you don't know. Try to find out if this solution itself is isotonic. It's simple. How do we find out? It's simple. You use the sodium chloride equivalent of ephedrine sulfate to move ephedrine sulfate to sodium chloride. Then, of course, you know that 0.9 gram of sodium chloride in 100 ml is isotonic. This solution is isotonic. That one is clear. Now, you move this ephedrine sulfate, move it to sodium chloride, and see the amount of sodium chloride represented by this 0.5 gram of ephedrine sulfate in 10 ml. Then bring down that 0.9 gram of sodium chloride in 100 ml to 10 ml. 0.09 gram. So that means 0.09 gram of sodium chloride in 10 ml is. Then ask yourself, if you bring this into sodium chloride, and if it doesn't give you 0.09 gram in 10 ml, that means this solution is not 0.09 gram. This solution is hypotonic. That means you need to add sodium chloride to make it isotonic. But if it is above 0.09 gram, that means this solution is already hypertonic. You don't need to add another thing again. So the answer is simply the solution is hypertonic. You cannot add extra sodium chloride. If you like, you can go further to talk about, but that one is not necessary. This solution is hypertonic. You cannot make it isotonic by adding sodium chloride again. So this sodium chloride is not necessary again. Simple. You've answered the question. You should be thinking of how to even, if possible, decrease the amount of ephedrine. But if you decrease it, it will affect the concentration of ephedrine in the preparation. It's no longer 0.5 gram of ephedrine you are producing. So this is already hypertonic. You cannot use it. Simple. You have answered the question. Any other thing you are trying to do with your complicated is a complex system which is beyond the scope of what we are discussing here. So this is what you should find out. So now let us find out if this solution is hypo, iso, or hypertonic. Let's find out. So remember, we agreed, I already told you, for sodium chloride, 0.9 gram of sodium chloride in what? 100 ml is what? isotonic. So in 10 ml, remember this preparation is 10 ml. So you have to bring it down to 10 ml. 10 ml, how many gram will be in 10 ml for it to be what? Isotonic. So X will now become what? 0.9 gram times what? 10 ml over what? 100 what? Ml. 0 will cancel 0. 0.9 divide ml will cancel ml. 0.9 gram divided by 10 will give you 0.09 gram. So that means 0.09 gram of sodium chloride in what? 10 ml is what? Isotonic. 0.09 gram of sodium chloride in 10 ml is isotonic. So let us look at this. Let us move ephedrine sulfate to sodium chloride using the sodium chloride equivalent of what? Ephedrine sulfate. Using the sodium chloride equivalent of what? Ephedrine sulfate. All right, let's go. By sodium chloride equivalent of ephedrine sulfate being 0.20, we mean that 1 gram of ephedrine sulfate has the same tonicity with 0.2 gram of what? Sodium chloride. That's the meaning. So if 1 gram of ephedrine sulfate is equivalent to 2 gram of sodium chloride, that means ephedrine here is what? 0.5. That means 0.5 gram of ephedrine sulfate will be equivalent to how many gram of sodium chloride? So the answer is what? 0.5 gram times 0.2 gram all over what? 1 gram. Gram will cancel gram. 0.5 times 0.2. That means half of 0.2. Half of 0.2 is 0.1. Yes. Half of, because this is 1 over 2 times 0.2. So half of 0.2 is 0.1. So the answer here is what? 0.1 gram. So in this solution, we only have 0.1 gram of sodium chloride because we have moved it to sodium chloride. So we have 0.1 gram of sodium chloride in 10 ml. So here now, this solution contains 0.1 gram of sodium chloride in what? 10 ml. But the one that is isotonic is 0.09 gram of sodium chloride in what? 10 ml. If you watch now, this is 0.1 gram of sodium chloride in 10 ml is higher than 0.09 gram of sodium chloride in what? 10 ml. And this is the one that will be there for it to go isotonic. But we have 0.1 gram in 10 ml. So this solution is hypertonic. It is hypertonic. And because it is hypertonic, you have no business adding sodium chloride again. If you mistakenly go and convert this to milligram and 10 and write that maybe if you convert this to 10 milligram, it becomes 100 milligram. You now say 100 milligram of sodium chloride need to be added. You are writing, you are solving nonsense because the solution this time is only hypertonic. So the simple answer is that this solution is only hypertonic. So it can't do anything again. And if you don't even need such solution for what you want to do or prepare, because it will be harmful. That's the answer to the question. You don't go and say if you add extra sodium chloride, you are making it more isotonic. Had it been that this thing is less than, let's assume this is 0.06, you cannot add extra sodium chloride to bring it up to what? 0.09. But it's only 0.1 gram, so it is hypertonic. So this solution, this question is here to test your understanding. There's some question like this. They may not ask you to calculate anything. The question will just ask you to check if this solution is hypo, or isotonic. That is also a question. With this, you can test, you can get eye drops and check whether it is hypertonic. Check the percentage, the number of the what is in the leaflet, maybe if the strength of the active ingredient and other ingredient anyway showcased in the leaflet. You can actually do a calculation to check whether it's what. Although there is not everything that you may see, but the basic thing, just theoretical, is you can use it to check. Okay, from theory, this is hypertonic. This is isotonic. This is what is it called? Hypo. Even the infusions you have. Okay, let's just do something practical now. 5% dextrose water. Is it hypertonic, hypotonic, or isotonic? Let's see whether it's true. Let's see whether it's hypotonic. I'm going practical now. But before then, I don't know if you have any question. Anyway, even if there's a question, please, if you have any question, drop your questions on the chat, on the comment section. I will see it immediately. I will see it and reply you. But I want to do something practical now. I want us to do something practical. Let's now use the one we know in the lab, in the hospital. 5% dextrose water. Let's use 5% dextrose water. Let's check 5% dextrose water. Let's check whether it's hypertonic or isotonic. So let's check whether it's hypertonic, whether it's true, actually true or not. Let's look at it. So I can clean the board now. Let's do something practical. With this, you understand the what we are talking about. There's my dust. Okay, let's do something else. Let me clean here. Let's do something else to buttress my points. Let's check whether 5% dextrose water is isotonic, hypertonic, or hypotonic. Now, by implication, 5% dextrose water means 5 grams of dextrose in what? 100 ml of what? 100 ml solution. That's the meaning. 5% dextrose water means this. So we have 5 grams in 100 ml. But remember that dextrose, anhydrous dextrose, that the what is it called? The circular equivalent is 0.18. So E value of anhydrous dextrose, let's use anhydrous dextrose, see how it goes, is 0.18. 18, yes. By implication, this means that 1 gram of this anhydrous dextrose, so this should be dextrose. 1 gram of this dextrose is equivalent to 0.18 gram of what? Sodium chloride. That's the meaning. It means that 1 gram of this is equivalent to 0.18 gram of what? Sodium chloride. That's the meaning. That 1 gram of this is equivalent to 0.18 gram of what? Sodium chloride. But remember something, that this 5% means 5 grams in 100 ml. The dextrose we have, it normally comes as 500 ml. That's 500 ml. So if you have 5 grams in 100 ml, how many grams will be in 500 ml? This also implies, if you have 5 grams in 100 ml, how many grams will be in 500 ml? So we have to multiply, if you multiply this by 5, we have what? So we have 25 grams in what? 500 ml. So we have what? 25 grams in what? 500 ml. 25 grams in 500. That is the meaning. The infusion comes as 500 ml. So if 5% working group means 5 grams in 100 ml, so we have 25 grams in what? 500 ml. But let us find out the amount of sodium chloride represented by this 25 grams in 500 ml of dextrose water. We already know that 1 gram of dextrose water represents 0.18 gram of what? Sodium chloride. So that means 25 grams will represent what amount of sodium chloride in that 500 ml. We call it X. X is now equal to what? 25 gram times what? 0.18 gram over what? 1 gram, which is what? 25 gram times 0.18, excuse me. 25 gram times 0.18 is 25 times 0.18 is 4.5. 4.5 what? Gram. So 4.5 gram. This 25 gram of dextrose in 500 ml for dextrose represent 4.5 gram of what? Sodium chloride. Sodium chloride. That's the meaning. Gram of sodium chloride. So the question is this. Remember, this is 4.5 gram of sodium chloride in 500 ml. That's the meaning, remember. That's the meaning. It means 500 ml because this is 25 gram in 500 ml. So if you move it to sodium chloride, it becomes 4.5 gram of sodium chloride in 500 ml solution. The question is this: is this thing isotonic? We don't know yet. Let's find out whether it is isotonic. Let's go back to the one we know that 0.9 gram of sodium chloride in what? 100 ml is what? Isotonic. We know this one, confirm this one, right? Because this is certain as saying 0.9% weight in volume. So 0.9 gram of sodium chloride in 100 ml is isotonic. Now, let's find the amount of sodium chloride in 500 ml. If the amount of sodium chloride in 500 ml is 4.5 gram, that means 4.5 gram of sodium chloride in 500 ml is isotonic. And by implication, 5% dextrose water is isotonic. So it should be used. So let's confirm it. So if 0.9 gram of sodium chloride in 500 ml is isotonic, that means how many gram in 500 ml will be isotonic? So S is now equal to what? 0.9 gram times what? 500 ml over what? 100 ml, which is 0.9 gram times 500 ml over 100. This divide this is 5. Ml cancel ml. 100 divided 500 is 5. Simple. And 0.9 gram times 5 is 4.5 gram. 4.5 gram. So it's 4.5 gram in 500 ml. So if 0.9 gram of sodium chloride in 100 ml is isotonic, that means 4.5 gram of sodium chloride in 500 ml is isotonic. And because it is isotonic, remember it represents 25 gram of dextrose in 500 ml. And 25 gram of dextrose in 500 ml is the same thing with 5 gram of dextrose in 100 ml, which by implication is 5% dextrose in water. So 5% dextrose water is isotonic. So it's correct, it's isotonic. So that's why you use 5% dextrose water as an infusion. Yes, it is isotonic. Okay, so if you have a question, please feel free to send it via the chat. Feel free to send your questions. Okay. I'll also give another 2 minutes to ask questions based on this thing I explained here. Just 2 minutes. Excuse me. Okay, let's look at another question. Let's look at another question. Okay, sorry, the question is taking time to come up. Just a few seconds, please. Okay. Okay. Okay, look at this question. Okay. The question says, zinc sulfate is a 2-ion electrolyte dissociating 40% in a certain concentration, full stop. Calculate its I factor. Calculate its I factor. To solve this question, we should understand the dissociation. You know, zinc sulfate is an electrolyte that has 2 ions, zinc ion and sulfate ions. So, as an electrolyte, it dissociates, but the dissociation is just 40%. That means that 40% of the zinc sulfate will dissociate, leaving 60% undissociated. And that 40% that dissociate will yield 40% zinc ion, 40% sulfate ion. So there will be an increase in the particles, in the ions there, in particles there, both undissociated and dissociated ions. So this will contribute an increase in the particles, and this will contribute to what? To increase in osmotic pressure, concentration of the ions and osmotic pressure, and will impact tonicity in the what? Solution. So if we put that into consideration, we'll now solve this question. Let's look at dissociation of zinc sulfate. So if we have zinc, this is zinc sulfate solution. It will dissociate to form zinc ion and sulfate what? Ion. Zinc here initially zinc was 100%. Everything is complete. That will use 100%. Everything, the number of particles. If you want to go to the exact number of particles, that means you start applying Avogadro's numbers, which we don't go to that extent. Just call everything, and when everything is complete, you say it's 100%. But you know that it dissociates. Initially, it was 100%, no dissociation. So here is still 0, and here is still 0%, and here is still what? 0%. But finally, after dissociation, what remains here is 60% will remain. And here, what is coming after dissociation is 40%. Here is also what? 40%. 40% dissociation. 40%. There is 40% dissociation. 60 will remain. 40% of zinc ion produced, 40% of sulfate ion. So at the end of the whole thing, the total percentage of the particles that remain in the system is undissociated 60, dissociated 40, making it 60 plus 40 is 100, plus 40 is what? 60 plus 40 is 100, plus 40 is 1/4 total. So I factor is actually percentage dissociated percentage of the final particles ratio of the percentage or the final what? Particles after dissociation, and the percentage of the initial what? Particles. Initially, what was here is 100%. So here is what? 100%. But after dissociation, what will remain is what? 60% plus 40 plus 80. 60 plus 80 is 140%. So here is what? 1.4. If you divide through, you have 1.4. So the I factor of zinc sulfate is what? 1.4. I factor of what? Zinc sulfate is what? 1.4. is 1.4. Let me go through it again. It's a 2 ion yielding zinc and sulfate. Initially, before the dissociation, it was 100%. So no particles, no dissociation. That's why here and here is 0. But after dissociation, 6% remain. 40% of zinc sulfate, zinc ion, 40% of sulfate ion. So I factor is percentage of final particles, that's percentage of final particles, or final percentage particles. Anyone, some will say no number of particles is okay. Final percentage particles over, or to make it, you can also simply say final particles over what? Initial particles. Final number of final particles over number of initial particles. It's okay. You can also say percentage final particles over percentage initial particles. It's okay. Final particles is what? 140%. Initial particles is what? 100%. So everything is now 1.4. So the I factor of zinc sulfate is what? 1.4. I factor of zinc sulfate is 1.4. So I don't know if there's any question. If there's any question, I will ask. If there's no question, we end it here for today. So I'll give like 2 minutes for question. 2 minutes. Okay, so in the absence of any question, we'll end our lectures for today here. Please, if you have any question, feel free to drop it on the comment section. You can as well chat me up on these numbers, any of these numbers, 081 3868 2003 07012 945891. Chat me up on any of these numbers and I'll respond to your questions. Please subscribe to my YouTube channel. The name is Pharmaceutical Schoolboy. Subscribe to my Facebook page. The name is Pharmaceutical Schoolboy. Follow me on Twitter, Instagram, TikTok. On Twitter, Instagram, TikTok at Pharmaceutical83. You can also follow me on AudioMark at Pharmaceutical-D-Schoolboy. Every Saturday from 7 a.m. to 7:10 a.m. I organize academic competition titled Academic Battle with Pharmaceutical Schoolboy. It's an online competition that features one subject per Saturday. Subjects from arts courses, science courses, medical courses, and even commercial courses. Registration is free of charge, and there are prizes to be won. Avail yourself of this opportunity. This academic competition will help you to grow academically. And the subject we have for the month this coming Saturday, being 2nd December 2023, is Igbo Language Battle 2.0 with Pharmaceutical the Schoolboy. Check out the flyers on my different social media platforms. Even in this YouTube, the flyers is there. Please, I need supporters, I need sponsors. If you want to make any donation towards this competition, please feel free to check out the flyer. The account details is there. Transfer to the account details and send evidence of transfer to the WhatsApp line there. And God will bless you if you do so. You can as well chat me on WhatsApp for more information. See you next time. God bless you.